Welcome to today's event, 7 points for coolant success with Blaser Swisslube. My name is John Einberger. I'm the product line manager here at Makino. One housekeeping item to get out of the way up front. What we'd like to do is get as many questions from you as you'd like for us to address. The way that you can do that, with the screen that you're looking at right now, the chat function in the upper right-hand corner that I have circled in red. Use that. We're going to see the questions as they come in, and at the end of today's presentation, we'll address all those questions. Let me introduce Mr. Glenn Lasley. Glenn, tell us a little bit about yourself and how long you've been in the industry.
I've been in the industry over 30 years. I've been selling the Blaser Swisslube product for about 30 years. Ohio, Indiana, Kentucky is my territory. So in those 3 states, I've seen it all.
So certainly a lot of experience at the table here today. So today's topic, very simply, 7 points for success for the use of metal cutting fluid in your equipment. Point number 1, Glenn.
Point number 1, where does it all begin? It all starts with good quality water. Keep in mind that water makes up 90-95% of a metalworking fluid, water-soluble metalworking fluid. So what defines good water? Good water is basically, we say, good quality drinking water. The main ingredients of drinking water, you could have some calcium, some chloride, some sulfate, some magnesium. All those things are good for us, but not necessarily good for metalworking fluids. Chlorides under a certain level, sulfates under a certain level, calcium under a certain level, magnesium under a certain level is what you want in good quality water for metalworking fluids.
So really wanting to start out not with water that's stripped of all these elements, some of that element content in the water is what you want as a starting point.
That's correct. You do want a little calcium. It aids in foam control and some other items in there, but there's other things you don't want a lot of. What ends up happening, though, is if you have those elements in there, as the water evaporates from the coolant, which is typical as you generate heat in a cut, some of those elements can climb, and some of them can climb rapidly.
So if we think about that evaporation, that's just pure water leaving the solution, so that concentration really goes up at that point in time.
Absolutely. The concentration goes up, and the concentration of salts and minerals in the water goes up. The way you could treat the water, you can deionize it, use a reverse osmosis filtration, or distillation, just depending on the quantity of water that you need. Water softening, that just removes the magnesium and calcium from water. Not necessarily good for coolant. It's just an exchange of ions where you remove the calcium and the magnesium and you put a sodium chloride back into the water. It does get softer, but that's not good for metalworking fluids.
Things that, again, maybe are good at the start, but in too big of a quantity, detrimental to that performance.
That's absolutely correct, John. Potential consequences of poor water quality. As the water evaporates, those salts build up, but you also have free oils, your tramp oils, your sludge, they all remain in the sump. As you can see the little graph here, on day 1, your salt level is acceptable, but as water is evaporating on a daily basis, if you're running 24/7, it would be a little faster. You can see on the second slide there, the salt level at day 100, how populated the blue is. Potential consequences of not treating your water. What you see here, we call this the Pac-Man, is an oil droplet surrounded by water. The blue pins in the oil droplet is the emulsifier that holds that droplet suspended in water. And what you see, the red and the green, is everything's fighting to pull that emulsifier out of the coolant. You can see the picture here. This is what you see in your typical machine every day. What we did is a side-by-side test where we have coolant here, and it looks really good. You see that in a daily operation. And then here you see where the calcium is actually plating out because you have too much calcium in the water. So you can see how dirty the machine gets.
So certainly from an operations standpoint, from a maintenance standpoint, that's good. Stay away from the detrimental effect.
Absolutely correct. What you have there is what we call plating out. You have the calcium attaching to all the surfaces, and it really gets nasty and hard to remove.
So moving forward, point 2. Point 1, again, just to reiterate, start out with good quality drinking water. Add the deionized water or the mineral-free water to make it up over time.
Correct. That way you're not adding those minerals every day.
Keeps it really in balance.
Yep.
So, all right, moving forward, Glenn, point 2.
Point 2, mix the coolant properly. In order to successfully emulsify oil and water, you need to mix it properly, and a good quality mixing device is always recommended.
Yeah, if we really think about it, that emulsification, we've got oil, we've got water. You know, you always hear oil and water don't mix, but that emulsification, that's kind of that magic of getting those two dissimilar items to really bond to each other.
Correct. We always hear the oil and water never mixes, but if you mix it properly with a good emulsifier, our jet mix and mini mix help a lot. There's also a device called a dosatron unit that also mixes coolant really well, and it keeps it in check.
Glenn, we see some plant installations where maybe they've got a centralized refill system. Which of these type units would you normally see in that central system that feeds multiple machines from the standpoint of makeup and things of that nature?
You actually see both of these in use like that. The dosatron unit is really good for that, and it's automated, and it does about 10 gallons a minute. The jet mix will only do about, depending on water quality, up to about 8 gallons a minute. So it's personal preference. They're both about the same price, and they're both pretty sturdy and very robust.
So really gets that job done.
Yes, sir. Now, mixing it properly, if there isn't a mixer available, sometimes maybe a smaller shop, hand mixing is satisfactory and acceptable. You just got to mix it really good. And keep in mind, when mixing by hand, always put the water in the bucket or the water in the sump and add the coolant to the water or the concentrate to the water as you stir rapidly. Remember, oil in last, OIL.
Pretty easy to remember.
Can't forget that one. Now, when you mix it improperly, you never add the water to the concentrate. You'll get what is called a reverse emulsion, which, as you see here, mayonnaise is a representation of a reverse emulsion. It gets pretty thick and it doesn't work properly.
So good in the cafeteria.
Yep.
Not in your machine tool.
Keep it out of your machine.
All right, moving forward. Point 3.
Point 3, maintain your proper concentration. Concentration control is critical. You don't want to use too much and you don't want to use too little. So maintaining the proper balance always helps chemically and biologically. Maintain your proper concentration. Check it daily. On the left, you see a standard refractometer, not battery powered or anything. It uses the light and it shows you a refractive index. That says right about 15%, where the blue and the white, that is your coolant. And on the right there is a digital refractometer. Both are very good. It's just personal preference.
So you don't want to go like this. You want to have something that really gives you a good scientific number to shoot for and to try to maintain.
That is correct. This helps especially if you've got a 1-to-1 refractive index. It will help you maintain proper concentration. Typically you maintain, you check it daily, but you maintain a coolant concentration. For most of our products, is a minimum of 5% up to 15%, or somewhere in between depending on your operation and the application.
So from the standpoint of concentration, can too much be a bad thing?
Too much, you get too much lubricity, absolutely, then you're using more than you should. A prime example, let's just say you want to maintain 7 to 8%, but the sump's at 15%, you're using twice the amount of coolant you need to. So, you top off with a lean mixture, you never add straight water or straight concentrate to the coolant. There's a good reason for that. Straight water, you never know. You take the concentration below the recommended level, and if you add straight concentrate, it never really mixes properly, and you're going to, again, use more than you need to.
So again, that whole idea that you talked about before, mix it up in the bucket, get that mix going, and then put that mixed lean concentrate or lean mixture back into the tank.
That's correct. You mix it lean, you top off lean, you'll use a lot less coolant. And the potential consequences for low concentration, as you can see, corrosion, odor, smell, poor tool life. There's a whole lot of consequences by mixing too little coolant.
All right, point 4.
Point 4, minimize your tramp oil. Always remove your tramp oil on a regular basis. Ideally, use a skimmer. If for some reason your shop doesn't have skimmers available for the machine, you can use a shop vac and just remove that coolant from the top of the coolant.
So get that not necessarily sludgy. It can be liquid, but whatever's floating on top.
That's correct.
Get that out of the system.
And tramp oil typically pops right to the top for most coolants, so you remove it on a regular basis. Use an oil skimmer to minimize the accumulation. You see a disc skimmer here, but you also see like a little belt skimmer. They have rope skimmers, coalescers. Anything beats nothing.
One of the things that we've gotten also from the standpoint of customer feedback, grease lubricated machines certainly have an inherent advantage. You don't have that oil that's going to lubricate ball screws, the guides, things of that nature, making its way down into the coolant. The feedback that we get is the use of grease that tends to stay on those moving parts, doesn't make its way as readily down into the coolant, kind of helps minimize some of this from ever happening.
And that's a good thing. So, keep in the back of your mind that the tramp oil also can be a food source for bacteria and cause odors, unsightly, sticky messes.
Next point, Glenn.
Point number 5, top off with a lean mixture, even if you take it down to a 0.5%. Try as best you can to avoid adding straight water, and also concentrate. Don't add straight concentrate to the sump. If you got to bring the sump concentration up, you can mix 10, 15, 20% with your mixers and add that to the sump. We'll bring your concentration back in check.
I know we've mentioned this a couple of times, but just really that is such a critical point to the overall success and the performance of that coolant.
It helps you use less coolant by doing this properly. Add a mixture, even if you take that down to a 0.5%, both the dosatron unit and the jet mix unit, you can take it down to 0.5%, and that works really well if you got too much concentration. If you need to add a lot more, you can turn the dial. Both of those are very easily adjusted and take it all the way up to 10, 15, 20%, even up to 28%.
So in some ways, maybe a little bit counterintuitive. If your sump is sitting there, so let's just say it's sitting at 15% and you want it down to be 8%, kind of that natural inclination might be just dump a bunch of water in there. That's going to thin it down real quick, but plays havoc.
Yep, always add a little bit. Always put a little of the concentration back into the machine.
Remember, we're trying to keep that water and that oil bonded to each other.
Yep.
Point 6.
Point 6, keep your sump full. You minimize the turnover ratio. So let's say you have 100% sump level, and now it's all of a sudden 80%, so you have 20% less coolant in there. So you have 20% less heat dissipation. You have 20% less space for chips and sludge and other things to go in there. So keep that sump level full.
So think about that from the standpoint of the 100% full versus the 80% full. All of those molecules of coolant have to do work. At 80%, you've got fewer molecules, they're working harder.
That's correct. And the heat dissipation, that's critical. If you got 80%, it's working much, much harder than it would be if you have 100%. It's like your car. It says use 5 quarts of oil, but you want to run 4, not good. Talking about the heat dissipation, your minimization of your temperature gain. Foam, sometimes if that sump level is below the 80% level, that pump can suck air and cause cavitation, which generates foam. Foam holds in heat, so your temperature, your coolant goes up. It's just a lot of bad things can happen if you're not keeping the sump full.
So last point, Glenn.
Point number 7, maintain your sump. Your sump is not a dump. You don't use it as a trash can to throw any number of things that don't belong. The sump should have tramp oils naturally, should have chips, other things, foreign items, food, paper wrappers, gum. It's not a trash can. So maintain the sump, don't use it as a dump.
Probably one of the more challenging things really from the standpoint of getting this point across in a lot of shop environments that we've seen, keep that garbage out of the coolant system.
That's correct. Used to be years ago when smoking was allowed in machine shops, you'd see cigarette butts. It was just an easy, convenient place to put, your trash, just throw it right in the sump. Not good. You can plug up pumps, filters, and then biologically, you don't want to do this. Nowadays, smokeless tobacco, sometimes you see these kinds of things in sumps, chewing tobacco, dip, and there's one other one that people have done years past. I don't see it much anymore, but spitting in the sump. You're putting your hands in there, don't do this.
Yeah, think about what your next shift operator might think about you doing this. Probably something you want to stay away from.
Undoubtedly so. You know, another thing that ends up happening is you're making chips some ways and somehow find its way around filters. You can fill up a sump with chips. Over time, it can really replace a lot of coolant volume. So that 80% that we were talking about, keeping your sump full, if it's full of chips, you're also overworking the coolant. It also becomes an area where it can hide and biologically things can happen.
You'll see a lot of times on a machine layout drawing where there will be certain maintenance areas that are on that layout drawing. One that you'll see very frequently is in the area of the chip conveyor, that area that's dotted lined in. Very important to maintain that as open area. It allows the removal of that chip conveyor, the ability to take the chips out to do maintenance. We'd all like to think of the coolant systems as being maintenance free, but reality is they do need to be pulled occasionally, sumped, put back into place, filled up with good fresh coolant. So in summary,
use good quality water, mix the coolant properly, maintain your concentration, keep tramp oil at a minimum. What makes a good Swisslube hydraulic and spindle oil does not make a good coolant, so try to keep that tramp oil down. Avoid adding straight water, and also critical, avoid adding straight concentrate for top off. Keep your sump full and maintain that sump.
It is not a dump.
That's correct.
All right. So thank you very much, Glenn. We really appreciate your time, your knowledge that you bring forward. We certainly appreciate what Blaser Swisslube brings to the industry. What I'd like to do now is turn it over to the questions that you were inputting during the course of today's presentation. We're going to address those on a one-by-one basis and see if we can expand the conversation.
Thank you very much.
Okay, Glenn, we have a number of questions that have come in today. Let me start with this one. Please talk about concentration percent versus the brick scale on a refractometer.
Okay, all metalworking fluids, water soluble, have a refractive index. The majority of our products are a 1-to-1 reading, and that's important. Typically, the manufacturer will tell you is a 1.1, 1.2, or maybe a 2-to-1 reading. So basically, when you look at your refractometer, it's reading in bricks. So if we take our standard product, 2000 Universal, and the refractometer is reading 5, 95% of what's in that droplet is water and 5% is the actual coolant. If it had a refractive index of 1.5 and it read 5, the actual reading would be 7.5. So hopefully that explained it a little bit. All coolants have a refractive index designated by the manufacturer.
Okay, next question that's come in. Can you clarify at one point, should we add water to the coolant or coolant to the water?
Okay, you should never add water to the coolant or the concentrate itself. Remember, oil in last. So you put the water in it. If you're mixing by hand, you put the water in a bucket and you add the concentrate to the bucket and you stir vigorously, depending on how much percentage you need. So if you wanted a 20% concentration and you had a 5-gallon bucket, you put 4 gallons of water and you add a gallon to it. That's actually a little heavy, but that kind of gives you the percentage. And then you would get the percentage of concentrate in that bucket, stir it, that way it emulsified properly. With the synthetic, it's not as necessary to mix it as carefully, but especially with oil-based or vegetable oil-based metalworking fluids.
Okay, next question that's come in. Can you talk about the effects of proper filtration and how that relates to the life of the coolant?
It is always good, especially if you're machining like cast iron. You can have magnetic filtration that will pull the fines out of the coolant, so you're not recutting the chip all the time. But filtration could be paper filters, a paper bed filter, or a canister type filter, or a bag type filter. And then you get into the micron size. Typically, the smallest you want to go with coolant is a 5 micron. Some of our coolants you can take down to 1 to 2 micron, which is really pulling any solids that may be suspended out of the metalworking fluid. But it's always good to have at least some type of filtration in your system, whether it's a bag, a cartridge, or a bed type filter, or even a magnetic type filter.
Yeah, the one that I'll add on to it from the machine builder's perspective, cyclonic filtration we found does a phenomenal job of getting the fines out of the coolant without stripping the lubricity out of the coolant at the same point in time. Next question, Glenn, that's come in: are vegetable-based fluids biodegradable?
No metalworking fluid is biodegradable. After it's been used, you need to make sure you dispose of it properly. Years ago, the theory was if we have a vegetable-based fluid that you could just dump it down a drain or dump it on the ground. Well, I guess if you wanted to throw away concentrate, that would probably biodegrade or degrade naturally into the environment, but you're wasting the concentrate itself and you're wasting the fluid. I would not depend on anything being biodegradable. If you have an accident, it's a lot friendlier to clean up, but nothing is really truly biodegradable once you've cut metal with it or you've got tramp oil into the coolant itself.
Okay, a little bit away from the coolant itself, Glenn, but let me pose the question anyway. If we wanted to distill water in our shop, what type of equipment would we need? Or would you have any recommendations on who to talk to about a subject like that?
I would go to a water filtration specialist, United Water, United Waste, anybody that does RO, reverse osmosis, deionized water would be someone I would talk to. Distilled water is typically more expensive because it takes a lot more energy to heat the water up, capture the steam, and get a distillation process going. DI or RO work just fine with 99.9% of all metalworking fluids, and distilled water can be very expensive.
Keep in mind also one of the things that we talked about a little bit earlier in the presentation, the need for that mineral content in that base water to start with. Using the mineral-free water as a top-up, certainly important, but that mineral content to start with, super important to the effectivity of the coolant. One last question that I see, Glenn, before we wrap up: how important is tramp oil removal, a system to do that to the life of the coolant?
That is extremely important. Just keep in the back of your mind that what makes a good way lube, hydraulic, or spindle oil does not necessarily make a good cutting fluid. And then you get contamination in the system. So you're putting tramp oil into the system, into your sump. And what ends up happening, it becomes a food source for bacteria. Also, it degrades your tool life, your sump life, your surface finish. Typically, we tell you 2% or higher in a tramp oil and volume in the sump is very detrimental to the process. So it's always good, whether it's a belt skimmer, a rope skimmer, centrifuge, anything to remove the tramp oil, coalescers, just get the tramp oil out. It's the best thing you could do.
Okay, we're going to wrap up today. I want to thank everybody who joined us today. You should get a follow-on email from us that's going to give you a link to be able to watch this event again, pass it on to your counterparts where you work. But again, thank you for your time, and we appreciate the really good dialogue at the end, and look forward to you joining us again down the road. Thank you.
Thank you.